We are now on block 2 from probability on page 273. Yesterday we conducted an experiment and we saw that some of you are not very good gamblers. Some of you are pretty good gamblers. And I will just have you know that yesterday, as I walked around, I picked which groups I thought was going to win, right? And my percentage yesterday, all for every hour, 100%. I was right every time.
Way to go, 7.
Yeah. I'm a good dice counter.
You can. I'm not a good gambler because I follow Jesus. Okay.
Okay. Thanks for adding that in. So, today's main purpose, and I remember, this is the one thing I remember in 7th grade math, because that was like not quite a long time ago, but kind of a long time ago. And it was the one topic in 7th grade math I remember actually learning. And I don't know why, I might have been kind of not so smart, but I could not figure it out. And I got it wrong all the time, and it really stressed me out. And I don't know why, because it's super easy to understand. Maybe somebody didn't explain it very well, or I wasn't listening, or something. But I just remember learning it. So you can tell me at the end of the lesson if I was just not very smart, or if it is legit hard, which it is not. Alright, so our main thing in this lesson is comparing and looking at the differences in theoretical probability and experimental probability. Okay, an experimental probability, you actually conducting an experiment. Yesterday I rolled the dice 12 times and got data, and I used that data to look and see what happened in my experiment. Theoretical probability is using the information I know about the object. So yesterday the object we used was a dice. What information do I know about a dice? What's on it? It's 6-sided. What is on it? 6 sides.
6 dots.
Which are 1 through 6. So I know that information about that object. So theoretically, I should land on an even number what percent of the time?
50.
50, because it is 3 out of 6 of the sides is 50% of an even number. So, theoretically, conducting my experiment, I can predict 50% of the time I'm going to land on one or the other. Okay? So, theoretically is based on the object's data. Experimental is conducting the experiment and using that data. They both should be similar. They're not always. They will become more similar the more experiment trials that you have. If I just roll the dice 5 times, it's probably not going to match up very close. Maybe a little, but not close. If I roll it 100 times, it's pretty much going to mimic and look the same. So, I kept saying in the back of my head there was something else I wanted to say. Go back to it at the end, and now I can't remember what that was. Maybe in a minute. So before we start, we have Chris here with a spinner. And A wants you to write down what letter you think it would land on and why. So right now, you're using your theoretical information to predict. So look at the spinner, write a letter on A and why you picked it. Okay, raise your hand if you voted for A. Hands for B. Hands for C. You like going for the underdog, huh?
I was feeling lucky, that's what he said.
All right. That was Aiden saying that. Whoever wants to go and beat him up.
What did he say?
So, so, how many spaces did A have?
Three.
Huh? Oh, yeah. 3. How many spaces did B have?
3.
3, and C had 2. So we should expect in our experiment that A and B should be pretty close tied for first. And we should expect in our experiment that C should be last. Okay? So now we're going to actually look at him conducting the experiment. So, he wants to spin this 20 times. He's going to stop after 5, and we're going to look and see if the data looks like it should. So, he spins, gets an A, gets a B, gets a C, gets a A, and then gets another A. So, who won here?
A.
Our theory said A and B should probably be close to tying for first.
No.
Is that the case right now?
No.
And then our theory also said C should be definitely in last. Is that the case here?
No.
It's tied in last. So that's only 5 tries. And that's what I started the lesson saying. The trials, if you just do a few, it's not going to mimic your theoretical and what's actually happening. So you need to conduct more. So he goes 5 more times. He gets another A, another A, a B, B, and a B. Okay, how many A's do I have? 5 B's,
4,
and C, 1. So theoretically, we said C was going to be in last. It looks like that now. Is A and B more closer to 50-50?
Yes.
Is it dead on 50-50 between them? No, but they're closer now that I had more trials. So I should expect with the next 10, it should get even closer. He does it really fast here. Okay. So, somebody help me. How many total A's?
7.
7. B's?
8. 9.
9. And C?
3.
4.
C wins.
Okay. Theoretically, we said C should be in last. Did that happen?
Oh, and the other one did.
With the 20 tries. Okay. And we said A and B should be close to being tying for first. Are they pretty close?
Yes.
Yeah, they be.
They're 2 away from each other. It's pretty close. If I did this spinner 100 times, it should be really, really close. All right. So now what we're going to do is actually write the math for it. And they like us writing the math in probability notation. Probability notation. And what that is this is an example of probability notation right here. What does the P stand for?
Probability.
So what this says is the probability of A happening is 7. Where did 7 come from?
The 7
The
times.
7 times it landed on A over 20. Where did 20 come from?
The total number.
The total number of trials. So the probability of A happening is 7 out of 20, a fraction. But a lot of times in probability, we like to look at it in another form of a number. What do we like to look at? Percents. If you want to know your shooting average, you want to know that's percent. If you want to know your batting average, you want to know the percent. Sports is loaded with statistics and probability. Okay? Determining what pitch to pitch at that player, you have established stats on the pitcher, stats on the batter, and stats of those two being competed against each other and putting the right pitch in the pocket. Okay, so much stats. So much. All right, so on 1B, this is what it's going with here, is us actually calculating and writing in probability notation. They got 7 out of the total of 20. So the probability of 7 out of 20 of A is 7 out of 20. Then 9 out of 20.
What's here?
0.95 answer.
Then the probability of C happening.
Come on, Siri.
Okay. So I want these 3 probability notations written for B, and I want them written side by side because we're about to write some things underneath them. So on 1B, write those probability notations down.
The circles with the A's also.
That is not the probability notation. So these probabilities are in fraction form. We want to look at them as percentages as well. So the proper way to find percentages as a 7th grader, I could have just done what? 7 divided by 20. So I could have done 7 divided by 20, got a decimal, converted it to a percent. The 7th grade way, and it's kind of easier to do this method in our head, is thinking of a proportion like this. Well, 20 times what is going to give me 100? 5. So I then do 7 times the 5. What is 7 times 5? 35. So what percent is A going to be landed on?
35%.
35% of the time A will be landed on.
That makes sense.
Okay?
Yeah.
Well, do we even... Oh, yeah. So then for B is 9 out of 20. 20 times 5 again. So what percent of the probability is B happening? 45%. Then we look at C and calculate that. And we see that it is going to be 20% of the time the spinner should land on C. That is our theoretical probability. No, I'm sorry, that was an experiment. We conducted the experiment. That was experimental probability. Now we're going to look at the theoretical probability and compare them and see if they were close to each other. Ready? Here we go. We first need to define a couple definitions. First is, what is sample space? Sample space is a set of all the possible outcomes of an experiment. For example, the sample space of a 6-sided cube dice is 1, 2, 3, 4, 5, 6. Those are all the possible scenarios. So that is my sample space. And I would suggest to write the example. I think the end of next week I'm going to have a vocab quiz where it's matching the vocabulary word to the definition and the vocabulary word to the examples. Most of them are common sense.
Were we supposed to write the examples from yesterday?
Yep, because I clearly said write the examples.
I wasn't here yesterday.
Then I have a YouTube channel that you go and look on.
I'm definitely going home to watch this video.
Okay. Now, yesterday we defined experimental probability, and it had a fraction that had some words in it. And today I discussed that theoretical and experimental is calculated pretty much the same. They're just done at different times. So theoretical also has a fraction. So the number of outcomes in the event over the total number of outcomes in the sample space. So if I am looking for the theoretical probability of landing on a 5, how many sides has a 5? 1 out of how many total sides? 6. So the theoretical probability of landing on a 5 would be 1/6. So, now we're going to calculate our theoretical probability and compare it to our experimental and see how well the experiment worked out. So, theoretical probability, I said, has worked basically the same, except this time I'm using the data from the object. So, from the object, our spinner, how many have A's? 3 out of how many total? 8. So that is my theoretical probability. I want to look at that as a percent. I can do 3 divided by 8 or 3/8. Convert it to over 100. 100 divided by 8 is 12.5. So 3 times 12.5.
37.
So this is 37.5% for the probability of A. Theoretically, what was our experimental probability of A? 35%.
That's close.
Were we close?
Yes.
Pretty close. If I did my experiment even more times, it should get closer. If I don't have rigged objects. We're going to talk about rigged objects tomorrow. Okay, let's look at the probability of B. Well, how many spaces are a B? 3. How many are total? Do I even need to calculate this? No, because it's the same. So B is 37.5%. Theoretically, what was our experiment? 45. Was it close? Not as close, but it was kind of close. If I conducted the experiment more, it should start looking more like this number, this percent.
I don't know why, but I multiplied by 4 instead of 3.
And lastly, let's look at the probability of C. How many sections have a C? 2 8, which is 1/4, which what we know is 25%. So that's our theoretical. Our experimental was 20%. Was it close? Kind of. If I conducted the experiment more, would it be closer? Yes, it should. Okay, and lastly, B sums up everything I've been talking about today. So, experimental. Where do I get the information from to give them? You two have been talking the whole hour. Where do I get the information from for experimental probability?
When they're actually doing it, and it could have probable case of this or the other.
Okay, so we can say conducting the experiment is where I get the information. So experimental, you're conducting the experiment. Theoretical, sounds like theory. Where do I get the information for theoretical probability? What am I looking at?
It's you. It's you.
What am I looking at?
The number of outcomes.
What did I look on this problem here? What did I look at?
The spinner.
A spinner. So I'm looking at the object.
That's what I said.
I didn't hear you. So if I am flipping a coin, I'm looking at the object. What data does the coin give me?
It has
Heads and tails. So theoretically, it should land on heads what percent of the time? 50%. If I conduct an experiment, it should get close to 50% of the time, it will land on heads. So theory is where you use the data of the object. And I, in 7th grade, for some reason, could not state the difference between those two, and I would miss that question every time. Should I have missed that question? It says it in the words, basically.
On the football field, though,
So,
you always have to call when they hit.
thanks for listening. Have a great day. Like, subscribe, and hit the notification bell. And peace out, home dog.
Aiden Rose on IG, Aiden Rose 3.